Hello and welcome to the Calculus Building. My name is Gregory Carlson, and we're going to now talk about a wonderful idea called Nero's stop sign. And this part, I want you to know that this part of the Calculus Building and this section, this explanation, is adapted from something called The Great Courses Change in Motion Calculus Made Clear. And it's by Professor Michael Starbird. And it's a very, very good explanation. It's just great. That's why I'm adapting it. And if you have a little bit of extra money burning a hole in your pocket, I would highly encourage you to purchase Change in Motion Calculus Made Clear, because it really goes into the philosophy of calculus, and it's just a really fun watch if you want to learn, really dig into it and learn about why calculus is the way it is. I'll put a link of it in the description. So let's talk about Nero's stop sign. We have Nero, who's quite the guy, and he's in his car, in his very fancy car, and he decides he wants to just drive around for a while, and so he takes off. And he doesn't notice that at the end of his street, there's a stop sign. Why Nero, do you ask? Because this is a take on Nero's paradox, where Achilles, the war hero Achilles, is chasing after a bunny and never is able to reach the bunny. So we're going to make the stop sign a stop sign, though, to make the explanation a little simpler. So he puts his foot on the gas, he's accelerating, and his speed is going to be equal to the amount of time he's been in the car squared. So he's getting faster and faster and faster, and he doesn't have time for stop signs, so he blows right on past that stop sign. And the police arrive and notice, and so they pull him over. And they say, hey, you just went through that stop sign, so we're going to give you a ticket. And Nero says, before you do that, I did stop at the stop sign. I really did. And in fact, I have a camera that proves I stopped at the stop sign. And so it turns out he did. He had a camera right here. And here he is. And he says, look, I was stopped at the stop sign. Do you see that? There's an image of me at that moment in time stopping at the stop sign. I fulfilled what the sign was asking me to do, and I went on my merry way. So there's proof that I stopped at the stop sign, at least for that one moment in time. Even though it was really, really short, I was stopped. Thank you, I want to be on my way now. And the police officer says, that's true. He looked in the law book, and it never said in the law book how long you had to stop at the stop sign. So maybe it's true. Maybe he really did stop there. But if Nero's right, and real life is like a movie where it's just a bunch of frames, one after the other, they're all still images, but when you watch them really fast, it looks like things are moving. If that's the case, and the universe has some kind of frame rate, then in a way that almost makes motion impossible. It means that my hand is never moving. It's just a whole bunch of still images. And that would be a really weird way for the universe to work. So unfortunately for Nero, there's two police officers in the car, and one of them is named Leibniz, and the other is named Newton, the inventors of calculus. And they say, let's test this claim that Nero really stopped for 1 nanosecond at the stop sign, or 1 infinitesimally small second. So they say, you should remember this formula from algebra, the algebra building, and it's the slope formula. The change in y divided by the change in x is equal to your rate. So they say, we're going to approximate this. Let's see. Let's take his average rate from 2.8 to 3. We're going to look at his average rate from 2.8 to 3. And so if we update our slope formula, it's going to equal f of the first value. So I'm just going to say f of time 2 minus f of time 1 is equal to, divided by time 2 minus time 1. So that's equal to your average rate of change over this interval, okay, 2.8 to 3. So let's plug it in. If we plug it in at the top, we plug it in, f of 2 is going to be 3 squared, which is 9, minus 2.8 squared. And we get 7.84 divided by 3 minus 2.8. So that's going to be 9 minus 7.84, which equals 1.16 divided by 0.2, which is 3 minus 2.8. Oops. 1.16 divided by 0.2. We get 5.8. So his average speed from 2.8 to 3 was 5.8. Let's see what his speed was getting even closer to the stop sign. Let's do 2.95 to 3. So that's going to be 3 squared is 9 minus 2.95 squared, which is 8.7025. And that's going to be divided by 3 minus 2.95. So let's do that really quick. Let's slap a negative sign on that and add it to 9. So on the top we get 0.2975. Down here we're going to get 0.05. So let's divide that by 0.05. And we see that the average speed over this interval is equal to 5.95. So you see that we're going a little bit faster average speed than before, and that should make sense because this time is a little later than this time. So he's getting faster and faster. So let's do one more. Let's check what his average speed was from 2.99999 to 3. All right, let's see what his average speed was there. So again, we're just going to follow this formula where we plug in the values. So it'd be 3 squared, which is 9, minus 2.99999 squared, which is 8.99994 divided by, I think that might be a floating point error right there, so we're just going to ignore that, divided by 3 minus 2.99999. So this is going to be, let's do it. Let's slap a negative sign on this and add it to 9. We get 0.00005999999 divided by 0.00. Actually, let me do it just so I don't make a mistake accidentally. It'll be 3 minus 2.99999. So that's going to be 0.00001. Okie dokie. So let's do it. Let's do 0.000059999 divided by 0.00001. And we get 5.9999. So it seems to me that as Nero was approaching the stop sign, Nero's average speed, what number does it look like it's approaching? Kind of looks like it's approaching 6, doesn't it? But that's not enough evidence. That's not enough evidence. Luckily, Newton and Leibniz had some cameras on this side of the stop sign as well. So what we're going to do now is we're going to take a look at his average speed on the other side of the stop sign. So let's look at his average speed from 3 to 3.2, say. Okay, let's look and see what his average speed from 3 to 3.2 was. Again, we're going to use the average rate of speed formula. And so that's going to be 3.2 squared, which is 10.24, minus 3 squared, which is 9, over 3.2 minus 3. So that minus 9 is equal to 1.24 divided by 3.2 minus 3, which is 0.2. So let's divide that by 0.2. We see that his average speed over that interval is equal to 6.2. Okay, and that should make sense. It looks like we were approaching 6 on the left-hand side, and so he's going 6.2. Let's see what his average speed was from 3 to 3.01. Okay, let's see what his average speed was over this interval. That's going to be 3.01 squared, which is 9.0601 minus 3 squared, which is 9, divided by 3 minus 3.01. So on the bottom, I'm going to get 0.01, and on the top, I'm going to get 0.0601. So let's take off the 9 and divide this by 0.01. And I get that his average speed over this interval was 6.01. And so we could do this one more time with two values. In fact, let's do that, and this video is getting a little long, so I will see you in Nero's stop sign part 2. So we can solve this mystery once and for all. Did he stop or did he not stop? If you like this video, please like and subscribe. See you in a sec.